This is the first in a series of videos I'm making this evening to help you study for your test tomorrow. This one has to do with work, not the kind of work you go to get a paycheck, but work in the context of basic physics. The definition we're using is something that occurs when a force causes an object to move away from the Earth's surface. We use the equation work equals force times distance in order to calculate that. And here's an example. Let's say that my dog Hayduke weighs about 80 pounds. If you do the math, you figure out that that's about 350 newtons of force that his paws put on the floor of my house. So 350 newtons is something we could refer to as his weight. If I want to set him up on the couch, maybe his paw hurts. I want to put him up on the couch and he doesn't want to jump. I would have to lift him up, let's say half a meter. So force or work equals force times distance. That would be 350 times 0.5. W, work, equals 175 joules. Remember that joules is the unit we use for work. It's abbreviated with a capital J. Something that it's important to keep in mind when we talk about this kind of work is that a distance has to be moved by the thing the work is being performed on. And that motion means that if something is held still, work is not done on it by this definition. The reading pack you had a little drawing of a woman holding a barbell above her head. And it said, is she doing any work? What seems as if she should be. It seems as if it takes hard work to hold something heavy above your head. But in this case, the answer is no. If you think about it, that makes sense. F or W equals F times D. If D is 0, it doesn't matter what the value for F is, work is going to be 0 as well. So let's look at some notes real quick. Work happens when a force causes an object to move. Work equals F times D. The units are joules, J. And here's where I worked out the problem about Hayduke the dog. 350 newtons times 0.5 meters equals 175 joules.